So we're going to look at two different types of factoring today. So GCF stands for, can you say that again for me, please? Greatest common factor, good. So they said common factor, we're going to do the GCF. And I'll walk you through this. This is a pretty straightforward process. This is one of those things, though, where you need to be pretty strong with your math facts or have a calculator in hand. So let's do this. Our goal is to try to divide this stuff by the biggest thing that we can and take that thing that we divided and use it as a factor separate from the expression. So I know that I'm going to have a GCF sitting out in front here. And I know that my parentheses here is going to have two terms because this has two terms. And I know that it's going to be a minus in between. All right, so however many terms you start with, you're going to have the same number of terms inside your parenthesis with a GCF, greatest common factor, out front. The trickiest thing here is figuring out what the GCF is, but if you do it one piece at a time, it's not that bad. So first we're going to look at the numbers. Think about the numbers 18 and 8. I want you to give me the biggest number that we can divide into 18 and 8. 2 goes into both of them. Is there anything bigger than 2 that goes into both 18 and 8? 4 goes into 8. I don't think 4 divides into 18, does it? No, not without a decimal. We want integer divisions. So I think it's 2, because the only other thing that goes, well, 3 goes in 18, but not, yeah, it's 2. All right, so I'm going to put a 2 underneath each of these, and I'm going to put a 2 in my GCF, because 2 is the biggest thing that I can divide out of both 18 and 8. Now, we can also divide some x's out of both of these because they both have x's to spare. Remember, when we divide x's, when we divide variables, we're basically just canceling them. So the question is the same. What is the biggest amount of x's that I can divide out of both of these terms? 3 is the biggest. I can divide 4 out of this one, but I don't have enough x's to get 4 out of this one. So 3 is the most. So if we're going greatest common factor, we're going to divide 3 x's out of each of those, and that's going to appear in our GCF as well. Now, all we need to do to finish this up is to do this division. Our answer is going to go right here. So 18 divided by 2 is 9. X to the third divided by x to the third. That's all just going to cancel, right? There won't be any x's left over. So it's just a 9 here. Second term, we've got 8 divided by 2, that's 4. And then x to the fourth divided by x to the third, we would have 1x left over after canceling, right? So 4x. And that's it. There's our GCF. Not too bad, huh? Not too bad. Let's try another one. Oh my gosh, this one has 3 terms. Crazy. That's all right, we can deal. We're still going to have a GCF. We're still going to have parentheses, but this time in our parentheses, we'll have 3 terms. 1, 2, 3. And I'm just going to use the same signs that I have here. So minus, plus, minus. Same thought process here. Look at these numbers. Focus on your constants and coefficients first. Think about the numbers 49, 28, and 56. What number can we divide out of all 3 of those? 7 goes into all of them. Anything bigger than 7? 14 goes into 28 and 56, I think. Does 14 go into 49 without a decimal? No, it's a decimal. Okay. So I guess it's 7 then. All right. So let's divide out a 7. So that means we'll have a 7 in our GCF. And then look at the 3 terms and look at the variables. Do we have x's that we can pull out of all 3 of those terms? This one doesn't have any x's to spare. So if I can't pull any x's out of this, then I can't pull any x's out of any of them. So that's it. My GCF is just 7. So I'll go ahead and do my division. So none of these x's are all going to stay here, but let's divide. 49 divided by 7 is 7. And this would be x squared. 28 divided by 7 is 4. That x stays. 56 divided by 7 is 8. And that's it. We're factored. So I'm going to give you about 4 minutes right now to tackle the next 6 problems. Get as many done as you can. If you don't get all 6 of them done, that's fine. The back side of this is going to end up being our assignment. So if you do finish all up to problem 8, you can go ahead and flip over on the back and work on 17 through 22. They're very similar types of problems. So I'll give you a few minutes to do that. We'll come back together, check answers, get my attention if you got some questions. All right, I want to give you a chance to ask questions on these. Anything that we need to talk about? Okay, and again, if you didn't finish all 6 of those, that's fine. As long as you got 2 or 3 of them at least done and you're getting correct answers, then good. And you got the right answers? Nice. Okay, now this next part, I want to give you a fair warning. There are a lot of steps to this. Now, it's not terribly difficult, but the hard part is going to be just remembering all the pieces and the steps to it. So, and we have done this before. So if some of you are thinking this looks familiar, you should have seen it at the end of last year, but we went over it about 2 months ago in between chapter 6 and chapter 7. So let this focus in. We are going to factor this thing. And when you factor a trinomial that looks like this, a quadratic trinomial, you're often going to get factors that are in this format. So for all of these problems on this page where it says factor each completely, you're going to get an answer that looks like this. We have several steps to get us to what goes in those parentheses. So let me walk you through the steps, and we'll do this a couple times. So first thing we need to do is identify values for A and B and C. Those numbers are going to come from the coefficients and constants that are in your quadratic. So when I look at this, I see on my squared term, it has a coefficient of 4. So A is 4. My linear term, that's the one where the variable is not squared, has a coefficient of negative 23. Make sure you get the positives and negatives correct for A, B, and C. And my constant term, that's the one without a variable, is 15. So that'll be my C value. Now, once you get good at this, you're probably not going to be writing down what A, B, and C is each time. You'll be able to just look at it and say, oh, that first number is A, that second number is B, that third number is C. But for the sake of our notes, let's get those down. All right, from here, we are going to build a diamond problem. And this is why I had you practice your diamond problems on your homework last time. And the way this diamond problem works is in the top, you're going to have A times C. In the bottom, you're going to have B. So for our problem, what is A times C? Does anybody know what 4 times 15 is? 60. And on the bottom, you're going to have B, which is negative 23. So we need to solve this. Remember, when we're doing diamond problems, you multiply to get the top, you add to get the bottom. So we need to come up with 2 numbers that are going to multiply to give us 60 and add up to negative 23. 20 and 3. 20 times 3 is 60. 20 plus 3 is 23. Oh, you want to make them both negative, though. Negative 20 and negative 3. Yeah, that works. All right. So we're about halfway done now. Let's pause for a minute. Remind yourself of how we got here. We found A, B, and C. We put them into the diamond problem. The thing you're going to have to remember is A times C in the top, B in the bottom. Okay. From here, we make a box problem. This is why I was asking you to specifically use the box when we were practicing this the other day. All right, so we built a box problem, and the box problem, this is the hardest part for me, is remembering where all these pieces come from. So what you're going to have in your box in these two corners, you're going to have your first and last term from your original quadratic. So my first term was a 4r squared, and the last term was a 15. And the other two corners, you're going to have the numbers that you just found in your diamond problem with a variable after them. We're using r's here, so we're going to have negative 20r and negative 3r. So this is the trickiest part for me, is remembering where all these pieces come from. If you're a visual person like me, you might want to draw some arrows here just to kind of remind you where everything came from. All right, we just practiced GCF, which is good because we're going to use that now. Look at our top row here and tell me, what would my GCF be for just the top row? What's the biggest number that goes into 4 and 3? 1. And what about my variables? How many r's can I divide out of both of these? Just 1. So this is going to be a 1r right there, because that's the GCF for that top row. Okay, now we just need to fill out the rest. Remember, this is like the answers in a multiplication table. So I'm going to go ahead and fill out above this. What would I need to multiply 1r by to get 4r squared? 1 times what is 4r squared? 1 times 4 would give me the 4. To get the r squared, I'm also going to need another r, won't I? You guys agree that 1r times 4r is 4r squared? All right, so let's do the same thing here. What would I need to multiply 1r by to get negative 3r? 1r times negative 3 would give us negative 3r. Last spot, what would I multiply 4r by to get negative 20r? 5? Negative 5? Negative 5, right? Negative 5. And double check and make sure this last one works. Does negative 5 times negative 3 equal positive 15? Cool. We are almost done. We just have to write down our answer. Our two factors come from the side here. It doesn't really matter which one comes first. I'm going to do my r minus 5. That's 1r minus 5. Here's my 4r minus 3. I could have done either one first, though. All right, my students always, when we introduce this for the first time, my students always feel a little overwhelmed just because of how many steps there are to this process. This is one of those things that once you practice the steps, you'll know the steps. The individual steps are not that difficult. I struggle the most with solving the diamond problem, and initially I struggled with remembering how to get this stuff filled out in the box. Once I got that stuff down, I was good to go. Okay. Thank you. Thanks. Here, take one of these. Let's do another. So I'm going to go through this one a little bit more quickly. But our goal here is going to be to try and internalize these steps, okay? All right, so step 1, find A, B, and C. And since again, we're doing an example here, go ahead and write them down. Once you've done a few of these, you'll find that you don't actually need to write A, B, and C down each time. I'm going to go ahead and write mine down though. A is 6, B is 23, C is 20. We're going to use these to create a diamond problem. And again, because these are my notes, I'll go ahead and write this down. I usually don't, but it's A times C in the top, B in the bottom. All right, A times C, that's 6 times 20. 120. B is in the bottom, B is 23. We are looking for two numbers that multiply to 120, add up to 23. 120, let's see, that's 60 times 2, no. 40 times 3, no. 20 times 6. 20 times 6, 15 times, what would it be? 15 times 8? Is it 15 times 8? Oh, that works. Hey, all right. 15 and 8 works. Because that adds up to 23. Cool. All right, from there we go to the box. Mr. Skaggs calls this the Xbox method. Who had Mr. Skaggs last year? Nice. You remember Xbox? Vaguely? It was a while ago and during a very busy time of the year. So all right, let's fill the box out here. So these first and last, remember those go in these two corners. So 6v squared and 20. And then our diamond problem answers with the variable go in the other two corners. So 15v and 8v. It does not. That's a great question. So these two corners can be flipped. You don't want to flip these two corners. Although you can get a correct answer if you flip these two corners. It usually is tougher for me. Can you put that phone away, please? Oh no, that's a calculator. My bad. Sorry. Carry on, ignore me. And I'm just going to draw some arrows so I can remember where all this stuff came from. All right, and then from here, this is for me, this is the easier part of the problem. I know how to do a GCF. So look at these numbers, 6 and 8. What's the biggest thing that goes into both 6 and 8? 2 goes into both of them. And they both have V's, but the most we're going to be able to get out of both of them is a single V. And then we just have to figure out what's going to multiply by 2v to give us these two things, and then figure out what goes here. So 2v times, well, I guess it's got to be 3v, right? And 2v times 4 would get us 8v. And let's see, down here, 3v times 5 would get us 15v. And then this last corner serves as a check. 4 times 5 is 20, it works. So final answer, 3v plus 4 and 2v plus 5, and we're done. All right, you're going to get quicker and quicker at these as you practice them. So let me tell you guys what you're going to do for your assignments. If you'd like to, you can just focus on the assignment. The assignment's just the back side of this. So if I were you right now, I would go ahead and start on 15 and 16 because it's just like what we did. When you get to number 17, you'll be switching back to GCF. That's what we did at the beginning of class. When you get to 23, you'll be switching back to what we just did right now. Okay, you guys got the rest of the period for that. Get my attention, ask me some questions if you got questions. Yes. 11 through 14, if you want a little extra practice, go ahead and tackle these. If you're feeling pretty confident, you don't have to do 11 through 14. Okay. So the back side is going to be the homework. The front side is our notes. I'm going to come around and stamp your special right triangles. If you could please have your blue stamp sheet out. If you were absent and you didn't get one of these, you know where to find them. Same place we find all of our extra copies. There was also a handout, a packet last class. Folks, I'll be with you in just a minute.